This video is for Chapter 10, Sections 3 and 5. We'll be covering the area of regular polygons and how to use trigonometry to help find the area of shapes that we can't find with regular formulas. We're going to start off by just defining the parts of a regular polygon and coming up with the basic concept of how we're going to work with them. So, a regular polygon is one that has all equal sides and all equal angles. It is both equilateral and equiangular. The sample picture is an equilateral, equiangular hexagon, or regular hexagon. All regular shapes can have a circle circumscribed around the shape. This helps us see why we call these segments the radius. They go from the center to the vertex, but those vertices are all touching the circle. This is the center of the regular polygon. It is also the center of the circumscribed circle. Distance from center to vertex. Now there's the apothem. The apothem is the perpendicular distance from the center to the midpoint of a side. This is a critical value because it represents the height of this triangle. And lastly, we have a side length. All the side lengths are congruent, and this is a critical value because it is the base of this triangle. So the major concept for this lesson is, first, find the area of one triangle. Now, for right now, the only way we know how to find the area of a triangle is 1/2 base times height, where the base happens to be the side and the height happens to be the apothem. So 1/2 base times height would be 1/2 side times apothem. And due to the commutative property of multiplication, we can say apothem times side. These don't matter. Now, if that represents the area of one triangle, all we have to do is multiply it by the number of triangles. And the number of triangles happens to always be the number of sides. So this eventually develops into a formula. 1/2 apothem times side times the number of sides. Where we need to understand that the idea is that the apothem times the side is the triangle and the number of sides is the number of triangles. That's our goal. Find the area of a triangle and then multiply by the number of triangles. In a hexagon, apothem, 1/2 apothem times side times 6. If this was a pentagon, 1/2 apothem times side times 5. Find a triangle, area of a triangle, multiply it by the number of sides. Let's take a look at how this would work for a few specific shapes. Okay, so now it's time to put that idea to work with a couple different shapes. We have hexagon, a pentagon, and I have the beginning drawing of a decagon here. The key idea here is to establish that the hexagon is a special one of these shapes and that we can use 30, 60, 90 right triangles to find the apothem and the side. Now, where the 30, 60, 90 comes from is what's important. The central angle, which we learned first semester, 360 degrees divided by the number of sides. Now, for a regular hexagon, 360 divided by 6 is 60 degrees. Every single angle inside here in the central angle is 60 degrees. Now, given that this is an equilateral triangle or an isosceles triangle, it's now becoming equilateral. The 60 is going to be cut in half so that this is 30 degrees here. And now that means with the 90 degrees here that this is 60. And we have a 30, 60, 90 right triangle. We can use that 30, 60, 90 triangle to find all the different parts we need in order to solve for the area of this hexagon. So let's start off by saying that the radius was actually equal to 12. If the radius is 12, using special right triangles, it is the hypotenuse. The short leg is 6, and the apothem just became 6 rad 3. So in our example, where the radius equaled 12, we now found that the side length was also 12, 6, and 6, and our apothem became 6 rad 3. At this point, we have all the information to finish. Area equals 1/2 apothem 6 rad 3 times the side 12 times 6 sides. Now, when we look at this, remember that 1/2 6 rad 3 times 12, 12 times 6 rad 3, that's the triangle. Here's the number of triangles. So, when we take this and put it in our calculator, we end up with 216 rad 3 units squared. And there's our first example of a hexagon with radius 12. Let's move on and let's take a look at a pentagon. Now I'm going to change up what information I start with. I'm going to go with a pentagon that has a side length of 10. That puts a 10 here, and that allows me to split this into 5 and 5, and there's another R. Now here's where the problem comes into play. This is not a 30, 60, 90. If I take 360 and divide it by 5 sides, I end up getting 72. So this angle right here is 72. When I cut that angle in half, 72 divided by 2 is 36. That means this angle right here is 36 degrees. Now, this is not a special right triangle, but we have the information we need in order to solve for the apothem. We have a 36 degree, we have an opposite side of 5, and the apothem is the adjacent side. We can use trig. We can now say the tangent of 36 degrees is equal to 5 over the apothem. If I multiply by a on both sides, I get apothem times tangent 36 equals 5. Divide by the tangent of 36 on both sides, and now I can find the apothem. I go to the calculator, 5 divided by the tangent of 36. And it comes out to approximately 6.882. I'll put down 6.88. Actually, I'm going to go all the way to 6.882. The more decimal places we use now, the better our answer is going to be at the end. So, I now have all the information I need. Area equals 1/2 the apothem 6.882 times the side, which was 10, times 5 sides. In this case, 10 times 5 is 50, and half of 50 is 25. I can break this down before going to the calculator to 6.882 times 25. That's close to 7, and 7 times 25 is 175. So 6.882 times 25 gives me an answer of approximately 172.05. 172.05 square units. So, there's my second example. What's really important here and to understand is that if this is not a special right triangle, this radius does not equal 10. It cannot be 5 and 10. If it was, this would be a 30, 60, 90. The hexagon is the only shape where the side length and the radius are the same. For any other shape, we must use trig to find these values. All right, let's move on and let's try something a little different. Let's try the decagon. Now, I'm going to utilize this space right here to find the area. So, new example, the decagon. Well, the only thing I can fill in right now is that I know I have 10 sides. Let's see if we can put together one more piece of information. And we're going to make this one tough. We're going to put in that this is 20 for the radius. Now, this is a difficult problem. as I draw my apothem down, I need to figure out this central angle. 360 divided by 10 is equal to 36. Now that 36 degrees has to be cut in half. 36 divided by 2 equals 18 degrees. So 18 degrees is my angle here. I can find apothem using cosine. So I will set up cosine of 18 degrees equals apothem over the radius, 20. Multiply by 20, and we've got 20 times the cosine of 18. And I've got 19.021. So 19.021 equals apothem. Okay, well, I can put that in here, 19.021. So all I'm missing now is my side length. To find the side length, though, I'm going to try to find x. And then I'm going to multiply x by 2. I can use trig to find x. Sine of 18 equals x over 20. Multiply by 20 on both sides, and I have 20 sine 18 equals 6.180. 6.180 equals x. Now I'm going to multiply that by 2, and I get 12.36. And that is equal to my side, because I have doubled it. 6.18, 6.18, so 12.36. I now have all the information I need to plug it into the calculator. I can take this and say 19.021 times 19.021 times 12.36, multiply that by 10, and then finally divide this answer by 2, and I've got an answer here of 1,175.5. 1,175.5 units squared. I'm going to check that one more time. 19.021 times 12.36 times 10, and then divided by 2. And yep, we've got ourselves our answer here. So this is how we use regular polygons and how we use trig to find these regular polygons. In class, we're going to learn about how to find the area of other kinds of triangles using trig, and we may just come back and find another way to work with this material. That's it for this video. You now have the skills to work on assignments 4 and most of assignment 5.